All right, good morning, everybody, and welcome to PDC's second webinar in our series on various PDC products and industries. My name is Kareem Afzal. I'm Vice President of PDC Machines, and joining me today is a panel of industry experts from PDC and also one of our partners here, WeldCoa, to talk to you about how diaphragm compression can support your business in the industrial and specialty gas industries. Today, we're going to go through a rapidly changing agenda. We're going to talk about PDC machines and our history and our philosophy of supporting our customers and our markets around the world. We will give you a virtual tour of PDC, taking you inside the operations that make our diaphragm compressors. Then we'll be joined by our industrial sales manager, Mike Walsh, who will give you an explanation of PDC's technology and also various applications where diaphragm compression can be used in the industrial and specialty gases market. We will then go on a virtual tour of one of our recent installations through our customer partner, Cryogenics and Youngstown Oxygen out in Youngstown, Ohio. And then we're joined today by Senior Product Engineer Jason Casper from WeldCoa, who will be interviewed by PDC's legend, Gary Gallo, who will talk about different trends in the industrial and specialty gas industries. PDC is a 43-year-old company started by my father, Syed Afzal, 1943, from a garage in southeastern Pennsylvania, just outside Philadelphia. We are a company that deeply believes in localized manufacturing, where we call ourselves PA proud, where the majority of our product and the components that go in our product are sourced within a 2-hour radius of southeastern Pennsylvania, right outside Philadelphia. We serve a multitude of industries here at PDC. So the industrial and specialty gas market is our bread and butter market that we've been servicing for those years. The transfilling and trailer filling and cylinder filling operations, a real key business and a core business for us here in the United States and around the world. And the early commercialization market for hydrogen energy and hydrogen refueling applications around the world. We have over 4,000 compressors as our installed base. We're the market leader in the United States transfill and cylinder filling business. We have rapid assembly lines that are able to produce product at quick delivery times for our customers. And in the hydrogen market, we're the market leader with over 50% of the world market share. At PDC, we deeply believe in a customer and market-driven focus. PDC, we listen to our customers and the market, and then we create solutions to solve your customer problems. We provide a world quality product, which is provided to the world's codes and standards. Wherever in the world a PDC compressor needs to be installed, we could meet any of those codes or standards, whether it's ASME, CE, Pressure Equipment Directive, KHK, High Pressure Gas Law for Japan, the Chinese pressure vessel codes, KGS for Korea, Australian requirements. Wherever it is in the world, we could support your code and standards requirements. PDC, we have a vision to seek to make the world its most productive self by using industrial and specialty gases. And then our hydrogen vision is to cultivate a business platform that propels fuel cell vehicle usage and hydrogen energy applications through the deployment of world-class infrastructure and service. And we do this through our world operations. So we have our headquarters here in the United States, and we have sales and service directly operated and owned offices throughout the world. So we have PDC China, PDC Korea, PDC Japan, PDC GK, and soon to be PDC Europe, which will be located in Germany. Our core industries, as I mentioned earlier, are the industrial gases and specialty gas transfilling business, a variety of industrial and specialty gas applications from oxygen cylinder filling, helium cylinder filling, hydrogen tube trailer filling for industrial applications throughout the Far East, Southeast Asia, and the Middle East, semiconductor applications, and the hydrogen economy, fueling and providing high purity hydrogen for fueling transportation, people mobility, buses, trains, trucks, material handling equipment, and so on. And how do we bring this to the market? We bring this to the market through our strategic partnerships, working with a vast network of regional partners and engineering partners to bring PDC compression technology with their local and specialized expertise to the markets that we serve. And WeldCo is one of those proud partners that we're proud to share this webinar with today. PDC is a proud partner in sustainability of the Philadelphia Eagles football team, and I will go briefly through their partnership in a slide coming up. With IVUS Energy Solutions, we're bringing novel hydrogen fueling technologies to a world market across the globe. And PDC is a partner with Argonne National Labs, which is a U.S. Department of Energy national lab in Illinois, where we are the patent licensee of pressure consolidations, which is a specialized algorithm for operating hydrogen refueling stations. Our partnership with the Philadelphia Eagles is part of their Go Green sustainability initiative. The Philadelphia Eagles are the leaders in sustainability in sport, where they have a microgrid that offsets all of their event usage of power at their facility. PDC will be supplying our simple fuel hydrogen refueling system, which takes water and electricity and produces high purity hydrogen fuel, to introduce a fleet of hydrogen fuel cell electric vehicles, hydrogen material handling equipment, and other various hydrogen technologies into their day-to-day operations. And it's a partnership that PDC is extremely excited about. And this simple fuel hydrogen refueler will be located adjacent to Lincoln Financial Field in South Philadelphia. At PDC, we're ready to meet the growing needs of the industrialized economy throughout the world. We have just expanded to have over 100,000 square feet of manufacturing space within our 3 facilities to support the industrial growth throughout the world. And we are growing and scaling for a lot of the markets that we're serving, whether it's industrial gas or also the growing hydrogen economy. And now we will go through a virtual tour of PDC in this video clip. And with that, I am really proud to introduce to you Mike Walsh. He is our Global Industrial Sales Manager for Industrial Products. Mike comes to us with 30 years of industry expertise. And with that, take it away, Mike.
Thank you, Kareem. Good morning, everybody. Good afternoon, good evening, wherever you may be joining us from. As Kareem mentioned, my name is Mike Walsh. I'm the Global Industrial Sales Manager at PDC Machines. I've been there about 3 years, but I have 35 plus years in the diaphragm compressor industry. So this morning, what I'm going to do is review with you what a diaphragm compressor is, why you would want to use it, how it works, and hopefully provide a little bit of education along those lines. So a diaphragm compressor is probably the most reliable compression solution for very demanding types of applications. By that, I mean they provide gas compression with absolutely no leakage to the atmosphere. They provide contamination-free gas compression, safe compression of corrosive gases, can achieve high compression ratios versus other gas compressor technologies, from very low to very high discharge pressures, up to 15,000 psi. Compression of a variety of specialty gases, very high purity, xenon, argon, krypton, explosive gases, toxic, flammable, pyrophoric, corrosive, oxidizing, a lot of gases that are very difficult to handle with typical piston-style compressors. PDC diaphragm compressors are used for a variety of the industrial gas, specialty gas, hydrogen energy, petrochemical processes. Hydrogen is probably the most common gas that our compressors are used with. Probably 70% or more of the compressors that we ship to the industry are being used for hydrogen in various different types of markets, but also nitrogen trifluoride, carbon dioxide, phosphine, krypton, silane, fluorine. So you can see a wide variety of different types of hazardous and high purity gases. What is a diaphragm compressor? A diaphragm compressor is a positive displacement reciprocating device consisting of a hydraulic and a gas processing system. The gas is compressed using a set of 3 metal diaphragms contained between a gas head and a hydraulic head. The diaphragms move through a contoured cavity in the head assembly to displace the gas, and they are flexed using pressurized hydraulic fluid. The oil is pressurized by a mechanical crankshaft and piston. Process gas remains completely isolated from the hydraulic system by the 3 diaphragms. So cross-sectional view of a diaphragm compressor, you can see the different parts of it. It consists of a crankcase with a flywheel-driven crankshaft. We're also moving towards some gear-driven models as well. That's connected to through a connecting rod to a crosshead attached to a hydraulic piston, which creates the hydraulic pressure in the compressor. Diaphragms are sandwiched in a contoured cavity and sealed around the circumference by a gas side O-ring, hydraulic side O-ring, and a secondary leak detection containment O-ring. Gas enters through an inlet process check valve and is pushed out of the compressor through a discharge process check valve. Here's a short video of how a diaphragm compressor works. Diaphragm compressor is a reciprocating machine, as I mentioned, that uses high pressure hydraulic fluid to drive 3 metal diaphragms. Hydraulic fluid is separated by the diaphragms and sealed by a set of static O-rings around the circumference. Static seals prevent process gas contamination and enable 100% purity of gas compression. You can see the diaphragms in the compressor moving between the 2 sides of the contoured cavity. Gas enters through a suction check valve. At the same time, the piston is driving from bottom to top dead center, compressing the hydraulic fluid. When the piston reaches top dead center, gas is discharged through the discharge check valve. Main spare parts in the diaphragm compressor are the diaphragms and the head O-ring seals. The oil is injected into the piston area through an integrated injection pump driven by the compressor crankshaft that provides hydraulic fluid on every stroke to the compression chamber. All PDC compressors include a leak detection system. The leak detection system monitors the integrity of the diaphragms and primary seal rings. A secondary containment leak detection O-ring prevents fugitive emissions escaping to the atmosphere. The leak detection system includes instrumentation, either a pressure switch or transmitter, and a pressure gauge. This provides both visual and electronic detection of any potential leakage while it's contained within the compressor. Leak detection system is quick acting and provides for alarm or shutdown of the compressor as necessary. This is a diagram of PDC compressor installations worldwide. As you can see, PDC has shipped compressors to just about every country and continent all around the globe. This is a summary of the technical aspects of our diaphragm compressors. As I mentioned before, suction pressure can be actually somewhat subatmospheric and up to and above. Discharge pressures up to 15,000 psi, capacities from as little as 1 SCFM up to 2,000 SCFM, depending on what the inlet pressure is. Stroke lengths from 3.5 inches to 7 inches. Rod loads up to 20,000 pounds. We have configurations of single and multiple stage compressors in vertical, horizontal, or horizontally opposed configurations, depending on space requirements and availability. And we can provide different types of packages, from a bare compressor block to be packaged through a third party, basic, standard systems, and customized systems. Our series include the PDC 3 series, which is our small 3.5-inch stroke series up to about 10 horsepower. Our PDC 4 100% series, PDC 4 150% series, up to about 50 horsepower, and our PDC 13 7-inch stroke machine, which obtains up to 200 horsepower. So there's a brief comparison of technology between a diaphragm compressor and reciprocating piston type compressors. Diaphragm compressors using static O-ring seals and metal diaphragms prevent any process gas from entering the crankcase, and requiring no need for a purge distance piece. As opposed to a piston type compressor, there will be leakage past the piston rings in the compressor, and if the gas can't escape to the atmosphere, or you don't want the gas escaping to the atmosphere, a purge distance piece will be required. Diaphragm compressors provide very high product purity. All the moving parts are stainless steel. There's static O-ring seals in the diaphragm, so there's no potential for any contamination getting into the gas. Quality of the gas in a piston compressor is not the same, typically, as the gas purity wants to be. Maintenance for a diaphragm compressor is usually limited to changing the diaphragms and the O-rings about every 6,000 to 8,000 hours, and that can be completed in usually about a 4 to 8 hour period. Piston compressors generally have much more frequent wear and tear of piston rings, requiring more frequent maintenance. So diaphragm compressors provide high efficiency. We can often generate compression ratios, depending on the gas, of 6 to 1, 10 to 1, even higher. We can usually compress gases in 1 or 2 stages, whereas a piston compressor for the same application may need 4 or 5 stages to do the same thing. Typically, noise levels of our PDC compressors are 85 dBA or less at 1 meter, versus higher than 85 dBA of piston compressors running at much higher RPM. Compression cost of ownership. PDC has industry-leading diaphragm life. As I mentioned, we get between 6,000 to 8,000 hours typically between maintenance intervals. Typical maintenance can be performed in about 4 to 8 hours, and we use proprietary diaphragm technology that significantly reduces spare parts utilization and extending the life cycle of the compressor. Some installations of typical gases and technologies are where our diaphragm compressors have been placed to Pi Welding Supply in Waco, Texas. This is a PDC 3 Series, model 3000-7500, discharge pressure of 6500 psi, compressing helium, argon, and nitrogen, 24 SCFM, and it's used for high pressure, high purity gas cylinder filling. An air gas installation in Long Beach, California, having a PDC 4 3500. This is a single stage duplex model allowing high inlet pressures and fast fill rates, rated for 3500 PSIG discharge pressure, supplying helium from 2 trailers to cylinders at 80 SCFM. Air Liquide in North Branch, New Jersey, PDC model 3550-2500, outlet pressure of just 25 PSIG, handling silane gas at 2.5 SCFM. Silane, as you're probably aware, is a pyrophoric gas and will catch on fire when coming in contact with air. So it's very important that the gas be contained within the compressor and no leakage. So this is purification of gases for cylinder filling. Purification Equipment Research in Hebei Province in China, PDC Model 300-2000 with a discharge pressure of 1750 PSIG, handling nitrogen trifluoride. Nitrogen trifluoride is a very, very dangerous gas, cannot escape to the atmosphere and cannot come in contact with humans or can be very dangerous. 32 standard cubic feet per minute, high purity gas cylinder filling application. Mayflower Distribution Company in Cerritos, California is a PDC 4 1000-3500, discharge pressure of 3500 PSIG, handling helium at 40 SCFM, primarily for cylinder filling provided to the balloon industry. Dollar stores are one of the major customers. PDC provides industry-leading support. We can typically do a proposal within a few days, depending on the complexity of the specification. Sometimes same-day response is possible. We utilize a growing local international presence, as Kareem mentioned before, having offices in China, Japan, Korea, soon to be Europe, with a vast network of worldwide partners. PDC is always at your service. PDC representatives are available to assist you at any time by phone, email, or by direct visit. Spare parts are always in stock, and in emergency cases can be shipped out within 24 hours of notice. PDC has the ability to provide competitive spare parts for other brands of diaphragm compressors. We provide on-site startup assistance and operations and maintenance training, and we always provide no-fee factory acceptance test witness and initial training if the customer would require it. So for that, thank you very much for listening this morning, and I will turn it back over to Kareem for further instruction.
Hi, everybody. So now we were going to go on a short virtual tour of Youngstown Oxygen Helium Filling Center. And now I'm really proud to introduce our interview today. So our interview today is with Gary Gallo. He is our salesperson who is responsible for the transfill and industrial gas industry in the United States and abroad. And also we have with us Jason Casper, who is WeldCo, a senior product engineer. At WeldCo, they are on a mission to support their gas distribution. From palletization to specialty gas filling operations and automations, they have continually innovated solutions that have reshaped the industry. With that, I'm going to turn it over to Gary Gallo and Jason to talk with us about these industries.
Good morning, everybody. Jason, can you join us, please?
Hear me, Gary?
Looks like we're having a little technical difficulty this morning. Jason, if you could hear me, could you join us, please?
Hey, Gary, can you hear me?
Please hang on, folks. We're having some difficulty getting Jason
There we go.
connected.
There we go. Jason, if you could hear us, turn your camera on.
Thanks for your patience, folks, while we work through this small technical difficulty. Jason, can you try to say something? It appears we may have lost Jason, so maybe we could take some question and answers while Jason gets reconnected.
Yeah, sure. So my name is Danny, by the way. I've been administering the chat for this webinar, and I've been filtering through the questions and promoting the ones that I think it would be good for our presenters to answer. So let's start with this question from Daniel P. He asks, hi, Kareem, please address API standards, applicability, and advise which data sheet we should use to communicate performance requirements.
That's a great and complicated question. So in the most recent API 5th edition, diaphragm compressors under a certain kilowatts have been exempted from the requirements for API 618. API 618 is a set of standards for reciprocating piston compressors, primarily from the American Petroleum Institute. And because many of those standards are in relation to technical requirements for piston machines, which have equipment like distance pieces, which have equipment like purging purged crankcases in relation to them. Those are really items that are not applicable to diaphragm compression. So when we talk about which data sheet should be used for the diaphragm compressor, filling out the process data sheet, the first 3 pages would be more or less sufficient so we can understand the process conditions, and then we can work with you on the remaining balance of what is applicable and what is not to your particular goals. So let's try to go back to Jason and Gary. I saw Jason was able to come back to us.
Can you guys hear me now?
Yes, great.
There we
All
go.
right. Sorry about that.
Nope.
Technology is a great thing when it works right.
Good morning, Jason. How are you?
Good morning. Good.
Okay, welcome to our Industrial and Specialty Gas webinar. We'd like to ask you a couple questions, starting with what trends do you see in the industrial and specialty gas markets now, and especially in COVID-19 times?
So for us, industrial and spec gas, we haven't seen much change post COVID-19. We did see a spike of medical oxygen filling equipment, a demand for that equipment immediately after COVID-19. Besides that, the industry as a whole seems to be running the same as prior. The past several years, we have seen a couple of trends. One of those is that people are going more towards high pressure cylinders, trying to fill 200 bar, 4,500 PSI, 6,000 PSI cylinders. More of a demand for high pressure cylinders out there than there was previous. And the other change that we've kind of noticed here is more spec gas. A lot of your medical and industrial fill plants are adding equipment to be able to fill spec gas at their facilities as well.
Yeah, and it'll be interesting to see what happens with our conventions like WeldCoa, or like Gouda, and the specialty gas conventions that we go to. I think we'll be seeing a lot more webinars and probably a lot less face-to-face meetings, unfortunately.
Yeah, all of our conferences have been canceled so far since the start of this, and not completely sure when we're gonna be able to start going again. And a lot of our travel, WeldCoa has been open the whole time, but we've had travel restrictions because of it. So being able to go on startups and go customer visits, that type of stuff has been delayed. So hopefully things will start moving along again.
Yeah, we hope so. Let me ask you, what is the most important factor for your gas filling plants as far as equipment selection?
For equipment selection, it's got to be reliability and automation. And reliability, if the equipment's not reliable, the operators are focusing on repairs or issues with the system rather than focusing on filling. And a lot of these facilities have reduced their maintenance staffs or not have them at all anymore. So the equipment, the operators are being tasked with multiple activities at a time, and if the operator is trying to do multiple tasks, the automation allows them to be able to do those multiple tasks while getting the same consistent results every time from the automation, doing the same steps every time, whether they're standing there watching it or not. And then the reliability allows them to focus on those other activities rather than trying to troubleshoot and work on what's wrong with the system versus just filling and increases the efficiency of the system.
Exactly. Well, when would you recommend customers to use diaphragm compressors, and why?
So we always recommend diaphragm compressors. WeldCoa is standardized on diaphragm compressors, and we've standardized it primarily for safety. Diaphragm compressor versus a piston style compressor. Our industry has had a number of fire incidences in the past because like Mike was pointing out earlier, the piston style compressor, there's a potential of putting oil into the gas stream, and a lot of our systems have high pressure oxygen going to the same mixed manifold that we have high pressure helium going to. So if you're putting oil into the gas stream that's going into process piping and fill heads and cylinders that are potentially going to see high pressure oxygen as well, you definitely have a fire risk there. So safety is the number one reason to use a diaphragm compressor in the application. Our most common applications are helium and hydrogen. Most facilities don't have liquid source, bulk source at their facility. So they're cascade filling off of tube trailers typically. So the cascade process, at the end of it, you got a lot of product left in your tube trailer that would be sent back to get refilled, and you're just shipping a lot of molecules back and forth. The PDC compressor allows you to draw those molecules out and pull the pressure down on those tube trailers as far as possible. We do offer booster systems as well, which are for low volume applications. But really, if you're going to be filling for more than 2 hours a day, the PDC compressor has a lower suction pressure, so you got less molecules going back in that tube trailer, and it runs more efficiently. And then,
Yes.
Go ahead.
Speaking of the lower in tube trailers, in the past, the PDC 3500, the single stage and simplex and duplex compressors were the go-to compressors, but since these tube trailers and helium's more difficult to get, our customers are starting to take a different approach and using a two-stage compressor to get, like you said, every molecule they can out of that trailer. And our two-stage compressors can actually go down to 50 psi on the tube trailers, and that seems to be the latest swing.
Our customers are on allocation, off allocation. It happens often enough that they're always concerned about how much they can draw out of those tubes and be able to utilize as much of it as possible every time.
Yep, exactly. Well, I appreciate you joining us, Jason, and I think we'll switch over and let Kareem go ahead with the question and answer it.
Thank you so much, Jason. Thank you, Gary. Really appreciate the expertise and joining us for that interview. So Danny, we'll take a few more questions here, and then I will encourage folks to continue the conversation and reach out to us on LinkedIn and through our email, which our bios have our contact information. And we would love to hear from you and continue that conversation offline, online, so to speak. So Danny, let's
Yeah, okay, so we got one from Ramaswamy, and they ask, are there any plans for the Indian market? Could be interesting to reduce pollution in some big cities.
It's a great question, Ramaswamy. So as recently as last week, IOCL's Indian Oil Corporation CEO had made some statements where he included that hydrogen was a very big part of India's clean energy portfolio and future. Certainly, as we know, LPG, propane, natural gas are a big component of fuel for the country. And there have been some pilot projects with IOCL in Faridabad, as well as another solar energy location, which have explored using a combination of hydrogen and natural gas in their rickshaw usage to reduce the NOx and emissions from the rickshaws by about 30 to 40%. So I think that there is a push and a wave coming for India, and especially for a simple fuel unit, we look forward to when the time comes. We are ready now, so being ready for supporting that market as it arises.
Great. Now, next we have a question from Roberto C. And he says, Roberto from CTSH2 Italy And he wants to know, what can you tell me about the gas temperature after compression?
Very good question. So it depends on the compression ratio. So I see also Syed Mujtaba, who I know very well from Saudi Arabia, has asked about compression ratios for these compressors. It depends on the compression ratio. So say in a on-site hydrogen application where an electrolyzer is coming in at 30 bar, we're pumping to a higher pressure tube trailer, higher pressure cylinders at 450 bar. We keep the average temperature roughly under 230 degrees C coming out of the head of our machine. So that's our general rule of thumb in terms of outlet temperatures. We then cool the gas through a series of coolers, which would be an interstage or an aftercooler, and that would bring the temperature down to a nominal amount over the ambient condition.
All right. And so the next one is from Michael J. And he asks, do you provide hydrogen compression for high volume, high pressure H70 hydrogen stations like heavy duty trucks or transit buses?
Great. So we do. So we provide those machines. So I could give some brief examples from my slides. So here you'll see on my slides are a number of conditions. So some of these compressors are pumping at 1,000 kilograms a day for bus fueling. In Foshan, China, we're filling tram service. In Chengdu here, we're at 500 kilograms per day. And as we're looking to an H70 future for heavy duty trucks and large volumes of buses, we're looking into scaling compressor technology beyond thousands of kilograms per day, many tonnage per day. So this is a new and budding market, and PDC is ready to address those challenges.
Gotcha. Okay, and we have one from Alex K. And he asks, how easy would it be to convert a machine made for one gas to be used for another gas?
Great question. So one gas to another depends on the gas's molar weight and density. So say for a compressor from hydrogen to nitrogen, it's a little more difficult to go from the light gas to the heavier gas than it is from the heavier gas to the light gas. The second consideration needs to be made for the hazardous area classification that the machine needs to be installed in. So for example, a hydrogen compressor has to be installed in the United States at a class 1 division 2 environment, or for someone with an ATEX or an IEC explosion proof requirement, we're talking a zone 2 2G T3 type of environment. So as long as the compressor is designed to be installed in a hazardous location, you could switch between, say, hydrogen and helium. You could switch between CO and nitrogen. It really depends on which set of gases that we're trying to do. And we have time, I think, for one more question, if there is one.
Yeah, we have one last question here in the Q&A. So Syed asks another question, and he says, what are your plans for simple fuel in Saudi?
That's a great question, Syed. So I would love to talk to you offline about that. We have designed simple fuel that it can meet any world standard with the same build. So whether it's in Saudi, Indonesia, Malaysia, Singapore, Australia, we have a project now for Australia. We have a project that we're commissioning in Japan to simple fuel. We're looking for Korea. So I know Saudi, certainly in the Saudi 2030 vision, it's really working towards expanding the portfolio beyond to many other renewable energy industries. So I would love to talk to you offline about that as hydrogen fuel cells and energy become more common for whether it's material handling, forklifts, or for small fleet of cars. We'd love to support you in that project.
Yeah, and we had one more question come in from Manfred, but Manfred, I'm going to direct you to one of our industry veterans offline, so we can get that question answered and you can sort of have a conversation with them. Yeah, and thank you everyone for submitting the questions.
That's great. And again, on behalf of Mike, Gary, and Jason Casper of WorldCoa and all of our customers around the world who help support our business and support the growth of industrial and specialty gases in the hydrogen energy world, we thank you for your relationship. We hope you're safe. We hope you're healthy. We hope as the world opens that we're all able to do so in a safe manner. And we look forward to continuing the conversation offline. Our next webinar will be the same time. It's a Tuesday, June 23rd. It'll be purely focused on the hydrogen energy economy and compression solutions for that market. As well as on June 16th, I am part of a panel for the Philadelphia Chamber of Commerce and on energy storage. And we'll be talking about various pathways to energy storage. With that, thank you so much. And we wish you all a wonderful and healthy day.